Climate change is one of the most important challenges our generation has to solve. As you may know, this is mainly because there is too much CO2 in our atmosphere. Through photosynthesis, trees absorb CO2 from the air and store the carbon in their wood. However, if the wood is burned, the stored carbon is released back into the atmosphere. This is why using wood in the construction sector is a great way to keep the CO2 out of the air. Whether wood is burned or used for products is decided early in the wood value chain, right in the forest, based on their quality. Harvested trees are sent to pulp mills, sold as energy wood, or delivered to sawmills. At the sawmill, wood is again sorted by species, dimensions, and quality, which affects payment for forest owners. Trading standards ensure fair classification. Here you can see a typical process line, including the camera system we installed. In the beginning, the stems are lying on a conveyor belt. After they pass a detector, a picture is taken from the cross-section of the stem. Next, the stem is passing a device which is measuring the length and the diameter. After that, an employee manually visually grades the roundwood to classes B, C, and D, where B is the best and D the worst quality. However, this manual quality assessment is very demanding and human eyes reach their limits, especially in off-peak times. This leads to a higher error rate and the sorting is very subjective. That's why our goal is to support this process by computer vision. During this industrial process, we saved a dataset containing the images, the dimensions, and the employee's quality decision. We trained a convolutional neural network, specifically ResNet-50, using a dataset of 1,440 cross-section images, each labeled with a quality class by an expert. The result is a model that can predict the quality of unseen images, such as this example of quality D. However, convolutional and deep neural networks are often considered black boxes, making it difficult to understand their decisions, even for their developers. To successfully integrate these models into industrial processes, it's crucial to build trust with users. This is where explainable AI comes into play. A simple yet effective method is GradCam. By allowing gradients to flow back through the network, GradCam highlights the areas of an image that were significant for the model's prediction. Here you can see an example of GradCam applied to our trained convolutional neural network, making it easier to understand the model's reasoning. Still, this approach doesn't specify which features were detected and to what extent. To address this, we developed a segmentation decision tree, or SegDT model. First, we annotated features in each image, for example resin pockets, reaction wood, and cracks, and trained a YOLO instance segmentation model to detect them. Using segmentation masks, we calculated numerical features, for example the number of resin pockets, the reaction wood area, or the crack size, to compare with Swiss trading standards or train a classification model. This approach achieves 80% accuracy similar to CNNs. We developed a SegDT-based prototype for decision support in roundwood sorting, which a user study showed to be more user-friendly than CNN plus GradCam and current systems. SegDT also provides feature statistics, aids employee training, and supports fair pricing. This tool makes sorting more objective, fair, and efficient, enhancing research efficiency from the start of the value chain.